Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zulkarnain B. Azman. My metric number is E21A0452. Now, I want to talk about introduction. What is subsurface mapping? Subsurface mapping in geology and petroleum involves creating maps that show geological features below the Earth's surface. These maps are crucial for locating oil and gas reservoir and are made using data from well logs, seismic surveys, and production data. Geologists use this information to identify potential reservoir and understand subsurface geology. Next, we move to purpose of subsurface mapping. The purpose of subsurface mapping is to locate oil and gas reservoir and understand subsurface geology. Subsurface maps are created by using data from well logs, seismic surveys, and production data, and they help to identify potential reservoirs and pinpoints areas most likely to contain oil and gas. Geologists plays a key role in subsurface mapping by using interpretations of depositional environments and structural features to create these maps. That's all for me. Thank you.
Hello and hi, Assalamualaikum. My name is Anas Shakir bin Mat Nazri and my metric number is E21A0456. Okay, now I would like to share about description for structure map. Structure map have a geological formation and unit. The map typically display different geological formation and rock unit present in a specific area. These formations are different by color or pattern, making it easy to identify and study their distribution. Next, structure element. Structure elements such as fault, and joint are prominently featured on a structure geological map. These elements represent the deformation and movement of the Earth's crust over geological time. The next point is strike and dip information. Strike and dip are fundamental measurement in the structure geology. The map includes strike and dip symbol or numerical value to indicate the orientation and inclination of rock layer and structure features. And the last point in this slide is topographic features. The map often integrate topography features such as elevation, contour, river, and mountain for understanding the relationship between geological structure and the topography help geologists interpret the geological history of an area. Okay, for this point, I would like to share about the geological structure map. Okay, and this point has the legend and symbol, scale and orientation, cross-section, and geological historian age. For legend and symbol, a legend is provided to explain the symbol and color used on the map. This includes symbols for different rock types, structure features, and other relevant geological information. For scale and orientation, like any map, a geological map includes a scale represent the relationship between distance on the map and actual distance on the Earth's surface. Additionally, it indicates the orientation of the map, typical alignment with cardinal direction. For the next point is cross-section. Some structure geological map, for example, map include this slide, have cross-section or profile view that provided a vertical represent of the geological features needs the Earth's surface. This cross-section help geologists visualize subsurface structure. And the last point is geological history and age. The map may include operations information about the geological history of the area, including the age of different rock formation. Its chronological context is crucial for understanding the evolution of the Earth crust in a particular region. Thank you.
Hello, my name is Siti Nurshasha binti Muhammad Qasim and my matric ID is E21A0668. The purpose of an isopec map in geology is to illustrate thickness variations within a tabular unit, layer or stratum. Isopecs are contour lines of equal thickness over an area, and they display the stratigraphic thickness of a rock unit as opposed to the true vertical thickness. Isopec maps are used in various fields, including hydrographic survey, stratigraphy, sedimentology, structure geology, petrogeology, and volcanology. Other than that, it also provides a more accurate picture of stratigraphic thickness. This is because they reflect the thickness of the deposited bed. Furthermore, isopec maps show the stratigraphic thickness between an upper and lower horizon. Hence, it measured the shortest distance between the two surfaces. That's all.
Hello, my name is Akam Salam bin Abi Anwar. My metric number is E21A0451. So I'm going to explain about lithospacing map. Lithospacing mapping is a crucial tool for subsurface mapping in petroleum exploration and development. It involves creating maps that show the areal variation in the depositional pattern that make each genetic sequence within the reservoir interval. These maps are constructed by extrapolating and lithospacing from the wall, which can be challenging as there will be mostly vertical and near vertical well development in the field. Next, lithospacing maps are useful for understanding the geometrical interrelationship of the various sedimentary bodies and for the measuring width and length of the various microforms. They can also help define the basin topography and bathymetry by picking out sedimentary depositors, dispersal patterns, and topographical features that may have influenced the distribution of sediment in the reservoir.
Assalamualaikum and a very good day to Dr. Nur Shahida. My name is Nur Fazrin Ilyani binti Muhammad Afandi with metric ID E21B0576. I am going to present the differences in function of each map. So first map is the structure map, which is a map which shows lines of equal elevation or depth for a selected macro horizon, and it is used to delineate the subsurface configuration of rock layers and identify structural features such as faults and strata boundaries. So structure maps are generated using well data and seismic interpretations to depict the subsurface structure. And then we have the lithofacies map, which is depict the spatial distribution of different rock types or lithofacies within a geological unit. So they provide information about the variation in rock characteristics such as grain size, sedimentary structures, and also fossil content, which is are essential to understand the sedimentary environment and geological history of a region. And then next is isopec map, which is a type of subsurface map that shows the thickness of a geological unit between those two surfaces, and they provide a 3D representation of the thickness of individual formation or reservoir. And isopec map offer a simple method of showing the distribution of a geological unit in 3 dimensions, and they display the stratigraphic thickness between an upper and lower horizon, which measured as the shortest distance between the two surfaces. So in summary, an isopec map shows the thickness of geological unit, a structure map illustrates subsurface configuration, and a lithofacies map display the distribution of rock types within a specific area. So each type of map serves a distinct purpose in subsurface mapping and contributes to the comprehensive understanding of the geological characteristic of a region.